An invert cone is a cone that is drawn with the rounded part on top with the pointed apex facing down. For this discussion, suppose this invert cone has a radius of 11 meters and the height of 29 meters. What this means is that the radius of the circle that we drew on top is 11 meters, and the distance from the top all the way to the bottom is 29 meters. In most calculus problems, there are two main ways to set up the coordinate for the inverted cones. One is to set up the coordinates so that the origin is at the center of the circle. And so in this case, we would set 0 at the center with the vertical axis pointing down. What that means is that the positive axis is pointing downward instead of upward. Usually we label this as y, but it can be x or h. In this case, if this inverted cone has the height of 29, then the distance from the origin 0 to the bottom is 29. Note that this is positive 29, not negative 29. Another way to set up the inverted cone is to put 0 at the bottom. Now, if we put 0 at the bottom, then this is simply an ordinary or the usual setup for the Cartesian coordinates. This is 0 at the bottom, therefore this is 29. If we set this up accordingly, then it doesn't really matter which setup we use. The answer should be the same. However, if the problem specifies that we set up one way or the other, we must use the method that is specified in the problem. For example, with the first setup, where the positive y-axis is pointing down, the radius of this inverted cone is 11 meters. If we pick any point inside the cone from 0 to 29, the distance from the origin 0 to this point is y sub I. And if we were to draw a circle at this yi, then the radius of this circle is r sub I. The distance from the origin 0 to yi is yi. And the distance from yi to 29 is 29 minus yi. There are two similar triangles here, the smaller triangle and the larger triangle, with the ratio r sub I over 29 minus y sub I equals 11 over 29. Again, side over side equals side over size of the corresponding similar triangle. Isolate r sub I, we have r sub I equals 11 times 29 minus y sub I over 29. And so this is the radius of the arbitrary circle that we drew, assuming that we set up so that the origin is at the center of the circle with the positive y-axis pointing down. For the second case, where the y-axis is pointing upward, positive, with the origin at the apex of the cone at the bottom. If we pick any point inside the cone, the distance from the origin 0 to that point is y sub I. So this distance is y sub I. Remember that the radius of this cone is 11. And so we will do the same thing. We draw the circle at the arbitrary point. The radius of this circle is still r sub I. There are two similar triangles here. The smaller triangle has the radius r sub I and the height of y sub I, the distance from 0 to y sub I. The big triangle has a radius of 11 and the height of 29. The distance from 0 to 29 is 29. So the ratio that we obtain the time is r sub I over y sub I equals 11 over 29. And so again, the radius over the height, the radius over the height. Isolate r sub I, we have r sub I equals 11 times y sub I over 29.